Assalamualaikum, my name is Nurahana binti Makfuzi. My metric number is MA22137. For introduction, for lab 9, free fall is according to the Newton's first law of motion. When an object is in motion, velocity is not equal to 0, where acceleration is equal to 0. Therefore, the object will continue to be in motion with constant velocity and in the same direction. Next, what is the free fall? Is the free falling object is a object that is falling under the sole influence of gravity. Any object that is being attached open only by the force of the gravity is said to be in the state of free fall. There are two important motion characteristics that are true of free falling object. First is free falling object do not encounter air resistance. Second, a free falling object on Earth acceleration downward at a rate of 9.81 meter per second square.
Okay, Assalamualaikum. My name is Muhammad Razin Akmal bin Azman. My ID number is MA22138. So in this lab objectives, for the first one, we need to investigate the kinematic of a free fall from test. And lastly, we need to investigate acceleration of gravity.
A very good day, my name is Vikran Hari and my matrix ID is MA22130, and I would like to explain about the equipments that we used throughout this experiment in this slide. First is a ping pong ball, second a smartphone where we will use the stopwatch to measure the time taken for the free fall, and third is a scale height where we can indicate our height for the free fall experiment. In this slide, I'll be talking about the experiment's methodology. The first step is set the fall height to 100 mm. Second is start the experiment by releasing the ping pong ball and start the stopwatch. Third, measure the falling time and record it in table 1. Repeat the experiment steps for the same height for 3 times. Fourth, perform the experiment for different height as stated in table 1.
Assalamualaikum, my name is Aizul Hakim and my ID number is MA22129. So now I'm gonna present about the result of the experiment that we do. So firstly, from the heights, we took a total of 7 different heights, which is the height from the ball to the ground. Next, for the fall time, we record the time 3 times, so we can take the average, and from the average time, we can calculate the velocity by dividing the heights to the average time. Next, from the data that we get, we can plot the graph of the velocity versus the falling time average. Then from this plot of graph, we can get a gradient, and from the gradient, we can get the value of the acceleration of gravity. And this is the calculation of acceleration of gravity that we get from the graph. And as we can see that we get the gradient of the graph, which is 1.67, and the acceleration of gravity is 3.34 meter per second square. Thank you.
Assalamualaikum. Hi, I'm Muhammad Akil bin Muhammad Azani with ID MA22139. Okay, we continue about discussion after the discussion with teammate. We have answered several questions. Okay, the first question is why there are some difference between experimental gravity acceleration with accepted gravity acceleration, that is 9.81 meter over s square. The observed experimental gravity acceleration is 9.978 m over s square, which differs from the accepted, that is 9.81 m over s square by 1.71%. The Earth's non-perfect spherical shape may be the cause of this disparity in radius. Gravitational acceleration is affected by the location distance from the center of the Earth. Random errors could also be affected in the observed disparity. Okay, we continue to the second question. From the data in table 1, what is the relationship between fall height and average of velocity? Based on data in table 1, the higher of the fall height, the average of velocity will be increased. And we go to the last question. In your opinion, what will happen to solution if we change the steel ball diameter 15 mm to diameter 20 mm? Explain why. In my opinion, the steel ball's elevation during falling should be decreased if its diameter is increased from 15 to 20 mm because of the increased surface area and resistance. The following equation represents this relationship. G equal to capital G and capital M times capital M over R square. The gravitational acceleration, or G, is oppositely related to the radius tools when the steel ball diameter is increased from 15 mm to 20 mm. Acceleration will decrease as the radius increase.
For the conclusion in this lab 9 freefall, based on the experiment objectives, we can conclude that the experiment that in an object in freefall is subject to only gravity. The velocity against average time graph shows that the velocity is directly proportionate to the height of descent. We can compute the acceleration of gravity using the graph, and we may also evaluate the relationship between the size of the steel balls and the object's velocity and fall height. That's all from us. Thank you.